Mass Transfer Kitchen. My name is Shantara.
I'm Laura. I'm Angela.
I'm Vanessa.
And today we're going to be cooking up one of our favorite desserts, tres leches. Tres leches is perfect for any occasion, from pulling an all-nighter for the senior design project, to watching the e-videos for 460, to cramming for your mass transfer midterm. The first step of creating tres leches is acquiring all of the ingredients. For today's recipe, we have some flour, some sugar, some milk, just to create the base of the cake, along with heavy cream, condensed milk, and evaporated milk to create our tres leches mixtures. So, let's get cooking.
Okay, today we're going to be measuring the time that it takes for our tres leches mixture to be absorbed by our cake. And we're going to be comparing the theoretical and the experimental. To do this, we're going to cut our cake into 5 slices, and then we'll set a set amount of the tres leches mixture and into these bowls, and then we'll measure over time how much has been absorbed by the cake. And then we'll compare that to the time that our theoretical calculations say that it will take.
Let the tres leches sit in the fridge. We'll go over some of the theory and calculations used in this experiment.
In the following calculations, the time for all the tres leches mixture to be absorbed by the cake, which is 56.2% cake and 43.8% tres leches, is estimated for both theoretical and experimental conditions. We begin with the following equation for general transient diffusion with no reaction or internal convection, where A is the tres leches mixture and B is the cake. We define a dimensionless concentration Y without external convection resistance. Y is equal to 56.2%, where Ce is the concentration at equilibrium and is estimated as CAS, and CaO is equal to 0. To get the Biot number, the following derivation is followed. Using the following boundary conditions, we arrive at a Biot number equal to KL over the diffusion coefficient. Here we define this to be equal to infinity because the porous material offers little resistance to diffusion of the milk mixture into the cake.
Using the Gurney-Lurie charts for a slab and using a Biot number of infinity for an average concentration throughout the cake, we find that XD is equal to 0.2. We define the dimensionless time as follows, where L is the height of the cake, DAB is 1 times 10 to the negative 7 centimeters per second, and T is the time for diffusion to occur. The value for DAB was chosen because diffusion through a liquid is on the order of 1 times 10 to the negative 5, and for a solid it's 1 times 10 to the negative 10. And for a porous material, a value in between was most reasonable. This is supported by our final experimental results. Solving for T gives 208 days for the tres leches mixture to absorb into the cake for a 1.2821 cake to tres leches mixture for a normal cooking process.
To help the mass transfer of the tres leches through the cake, we are going to put holes in a uniform way.
We're assuming that we're creating uniform holes across the whole cake.
The edges, because they are not smooth and have a rigid boundary.
Ooh.
Cut it, 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 cut it. Them bricks is way too high, you need to cut it. Your price is way too high, you need to cut it.
What's the height, Vanessa?
It's 3 centimeters.
We are adding one third cup of tres leches to each cake, and we'll leave it in for a certain amount of time. After each amount of time has passed, we'll take the cake out and measure the remaining milk that remains in the bowl.
This is
So it's been an hour and we just removed the tres leches cake from the mixture that it was absorbing from. And now what we're gonna do is measure the amount of tres leches mixture that wasn't absorbed by this cake. And we'll do this for the rest of the 4 pieces of cake, and then from that we'll extrapolate the time that it takes for all of this to be absorbed.
too late.
It's okay. Oh. So that's 1/2 teaspoon?
We know.
So left. Just catch this last bit. This is another 1/2 teaspoon. Another 1/2 teaspoon. That was 3, right? Okay. Four. And 5. Okay. You can see it's only soaked to the first bottom half of the cake.
Or just in the back.
Mass transfer increased slowly and then reversed after 18 hours. The absorbency of the cake was most likely compromised from long exposure to cooler temperatures in the refrigerator. Additionally, external forces most likely stopped the tres leches mixture from being fully absorbed. I will now compare the experimental versus theoretical results. Theoretical prediction for the time it will take for all the tres leches mixtures to be absorbed was 208 days. By extrapolating experimental data, we can see the cake will most likely never absorb all the tres leches because the absorbency goes down after 18 hours. The large amount of time estimated from theoretical calculation agrees with the first 18 hours of our experimental data, but does not account for external forces acting on the liquid diffusing into the cake that will prevent it from fully diffusing into it. Following 2 references were used to help make this experiment. First is the recipe from the cake, and the second is our textbook.